Another type of graph we might see are graphs of equations of the form a plus or minus b sine theta or a plus or minus b cosine theta. These are called limacons. There are three types that we might see, so we'll look at this one first if the absolute value of a is equal to the absolute value of b. So if the coefficients here, or these numbers, are equal, then this limacon has one heart-shaped loop, and it's called a cardioid. It looks like a heart. All right, so if we have r equals 2, let's look at this one, minus 2 cosine theta. We're gonna have, it's gonna be on the x-axis since it's cosine, and we're gonna be on the left side due to this minus 2 coefficient for the cosine of theta. All right, so we're gonna have 0, twos above and below, and then 4 out here. So we get a shape that looks something like that. All right, so these values here are just this number, whatever that is. These are 2. Right. This value out here is the sum of the absolute values of these numbers. And if we take a look at what happens as we proceed around the angular measurements, we have theta equals 0 is going to give us this origin there. We're going to be here when we're at pi over 2. Here when we're at pi. And then here when we're at 3 pi over 2. And then back here when we get to 2 pi. Not 2 pi over anything, just 2 pi. Right? If we look at r equals 3 plus 3 sine theta, we're going to be on the y-axis. We're going to be above the x-axis because we have a plus 3 sine theta. We're going to have the origin here. We're going to have 3 and 3. These values here come from that number there, the 3, the constant in the front of the first term in that sum, and then the sum of the absolute values of these is 6. Whoops! So we're going to be 1, 2, 3, 4, 5 here. So we're going to get a shape that looks something like this. Like that. All right, and again, let's think about what's going to happen. We're going to be at this point here when theta equals 0. When theta equals pi over 2, we're going to be here at the top of this heart shape. We're going to be back here at theta equals pi. We're going to be this origin 3 pi over 2, which is also negative pi over 2. Next up is we're going to talk about when the limousin has one flattened loop, and this is going to happen when the A value is larger, or the absolute value of the A value is larger than the absolute value of the B value. All right. So before we get to that, let's look at these ones where we had a point that touched the origin. And the reason for that, of course, is that cosine and sine vary between -1 and 1. So if cosine is equal to 1, then 2 minus 2 is 0, and we kind of touch that origin. In the same way here, if the sine is equal to -1, we get 3 plus 3 times -1 is 0, and we touch the origin there. When we're talking about the A value, the absolute value of the A value is larger than the absolute value of the B value, in other words, this number is larger than this number, then even when the sine is equal to 1, we're only going to get a 5 minus 3 is equal to 2. So the 2 is as close as we can get to the origin. So we're not actually going to touch the origin. Closest we can get is 2, so here we're going to be on the y-axis, and the largest part of our shape is going to be below the y-axis because we're subtracting 3 sine theta. So we have 5 minus 3 here. We have 5 there, and we have the sum of the absolute values of these numbers, which is going to give us 8 here. So we get a shape that has kind of one flattened side, and it looks something like that. Alright, the last example is where the absolute value of A is less than the absolute value of B, so this constant term is less than the absolute value of the coefficient. And here we can see that if we have a 2 here, if the cosine becomes -1, then we're going to have 2 minus 4, so we're actually going to get a negative radius. And this is going to give us 2 loops. So let's take a look at what happens when we have this kind of an equation. All right, we're going to have a shape that's has x-axis symmetry because of that cosine. All right, we're going to have we are going to cross the origin. We have if cosine is equal to -1, we're going to have 2 minus 2 is -2, so that's going to put our inner loop here. When cosine is equal to 0, we're going to get 2, so we're going to get 2 and 2 there. And when cosine is equal to 1, we're going to get a 2 plus 4, which is going to give us a 6. So the shape that we're going to get is going to look something like that. Alright, so let's think about what happens here as we rotate around these angular measurements. When theta is equal to 0, cosine is equal to 1. Excuse me. So we get 2 plus 4 is 6. So this is our theta equals 0 location here. As we move around here, the cosine of theta equals 0. So here is pi over 2. And so our r is 2. Now as we move around this way, our cosine becomes negative. So we have by the time we get to pi, we have 2 plus 4 times -1, so it's 2 minus 2. So our angle is pointing here to the left, but we're taking 2 steps back to get to this point. Then as we rotate around this way here, we're getting closer and closer to 3 pi over 2, where the cosine is again equal to 0. So our r is equal to 2, and of course we continue around to 2 pi, and we get back to that 6 location.